Welcome everyone. This is 5 minute structure and here I am Pranav. So today's topic will be how to calculate block shear failure resistance. In this tutorial, I'll show you the block shear failure pattern and what equation will be used to calculate block shear failure resistance and each of the term in the equation and how you can find out from the CIC handbook. So let's start from here. So the block shear failure pattern. So you see the block shear failure will happen in any structural member when there will be tensile failure and shear failure simultaneously. So in here, let's say this is a W-shaped beam is connected with let's say plate, and this is the configuration. So let's say the block shear failure pattern will be like this blue line and the red line combination. So the blue line is the parallel to the applied load. So in this direction the shear failure will happen, and the red line is perpendicular to the applied load where the tensile failure will happen. Now this is another kind of figure where we'll see like a coped beam. There is a cope is connected with a plate like this configuration, and here is the applied load, and let's say here is like the block shear failure pattern. So the blue line is parallel to the load that will follow the shear failure, and the red line is perpendicular to the applied load. That means there will be tensile failure. So I told you before, like the block shear failure will happen if tension and shear failure involve simultaneously. And the tensile resistance for the block shear failure will followed by this equation. So the red portion comes from the tensile resistance and the blue portion comes from the shear resistance. And we all know like the performance factor at ultimate point will be 0.75. AN represents in this equation as net area in tension. AGB represents the gross area in shear, and the last UT efficiency factor. This is a new term in my tutorial, so let's start how we can calculate the efficiency factor. So the efficiency factor you will get from the CIC handbook page 253 from figure 226. So you see different types of block shear failure pattern you can find out from your structural member. And in here we see like 13 types of combination. So you have to find out what types of pattern will be followed in my exercise, and then you will get the value UT from here. So this is a 2-dimensional and this is a 3-dimensional block shear failure pattern, and this is the equation. So now I'll show you a simple exercise for in this tutorial, and I'll show you another advanced exercise for the block shear failure pattern or resistance. So a W-shaped member is connected with a plate. The load is applied along this direction, and the blue line will be the shear failure, and the red line will be the tensile failure. So for this type of configuration, we will find out the similarities from the number 7 where the UT value is 1. Symmetrical block shear failure pattern will follow in here. So the end distance is 40 millimeter. I told you before the end distance will be from the center of the hole to the like outer edge along the direction of the applied load. Center to center spacing of hole is 80 millimeter. So center to center is 80 millimeter. Hole diameter, let's say 22 millimeter. Let's say the condition is drill. Beam is W460 and 106. The thickness of the web is 12.6 millimeter from the CIC handbook. And let's say the material will be 350W. Now the UT value is 1. I told you before. Now how you can calculate AN? So AN is the area, net area for the tensile area, tensile portion. So this is the, from this red line you have to find out the net area. So you see just 1/4 of the hole is considered in here and 1/4 is in here. So half of the hole and half of the hole will be considered and deducted from the like 80. And its drill condition, so we'll consider 2 millimeter additional, and overall times the thickness of the beam web. So this is 705.6 millimeter square. Now AGV, that is shear area, gross shear area. So there are 2 line in here. Okay, so let's say the center of the hole to the center of the hole is like 80 millimeter, 80 millimeter, and 40 millimeter, and we have 2 blue line. So 40 plus 80 times 2 times 12.6 is the thickness of the beam web times 2. This 2 is comes from like 2 blue line. If there is a 1 shear line, then you will consider just 1. So that gives you like 5040 millimeter square. Now if I put all the values in this equation, then I'll get the value as like the tensile resistance for the block shear failure pattern is 1145.34 kilonewton. You will get the value as Newton, and you will divide that by 1000, and you will get that value as a kilonewton. So today is up to this. Thank you. Please subscribe the 5-minute structure.